Hey, welcome to NASA Launchpad. I'm your host, Amber Whalen. So today, we're talking about the Earth's radiation budget. Here it is in a nutshell. The Earth gets energy from the sun. Some of that energy is absorbed, and some of it's sent back out into space. If the Earth absorbs more energy than it emits, it heats up. If it absorbs less energy than it emits, it cools down. Seems pretty cut and dry, huh? Well, things are never as simple as they seem. There are a lot of little variables in the way. NASA keeps an eye on some of those variables using Ceres instruments on satellites to measure the amount of energy leaving from the Earth. What are Ceres instruments? Ceres is short for the clouds and the Earth's radiant energy system. Ceres measures visible and heat radiation, and for nearly a decade now has been observing clouds and the radiation budget. A new sensor, the Ceres Flight Model 5, will continue gathering information, adding to more than 30 years of climate data of Earth's radiant energy. While incoming and outgoing radiation amounts may change, especially the balance between outgoing light and heat, the overall radiation budget is in near balance. One of those variables we mentioned earlier is clouds. Changes in clouds may affect Earth's radiation budget, and changes in the radiation budget may affect Earth's temperature and climate. We've learned that clouds play a significant role in the Earth's radiation budget, but we don't totally understand this role. The long climate record from Ceres helps better understand the importance of clouds. And you can be a part of gathering cloud data too. There's a NASA program that you can get directly involved in. Yes, you watching this right now. It's called the Ceres School Project. That's school. Students, Clouds, Observations Online. Let's find out more by talking with an expert on school, the director of the project, Dr. Lynn Chambers from the NASA Langley Research Center.
It's a project that we started just about 12 years ago to involve students in some science that we're doing here at NASA that they can also participate in at their own school. We are looking at the radiation budget of the Earth, and in particular we're looking at how clouds influence that. So that's really controlling the temperature of the Earth, much like your thermostat at your house controls the temperature of your house. And so the student observations of the clouds give us some very important information to sort of help us understand how that's working.
Cool. So how does it work?
We ask for students to make an observation within 15 minutes plus or minus of the time that Ceres passes over. So you go onto the website and find out what time that is for your location. Then you go outside, there's a one-page report form that you can take out with you. You fill in the form, and then you come back to the computer and send the data back to us. And then if all goes well, about a week later you'll get an email, or you can just go back to the website and you can actually see the satellite information for that day alongside with what you reported so that you can look at that comparison.
Kind of makes sense, doesn't it? I mean, if you're studying something, you don't want to be just looking at it from one side, which is what satellites do. Satellites look at clouds from above, and even though some of the instruments scientists use can see into the clouds, they're still not getting the full picture. By getting involved with the Ceres School Project, you're looking at the clouds from the bottom up, helping fill in the gaps. Scientists actually use student observations to help verify ground truth. These observations help scientists determine if they're seeing from space what the ground observers are reporting. But hey, a cloud's a cloud, right? How will your observation make a difference? Well, let's go back to Dr. Chambers for a second and find out.
You can obviously see a lot of things near the surface that you're not going to see with the satellite, but some things that we have found, certain times contrails are not observable from the spacecraft because they're just far too small. Sometimes you have just a little bit of cirrus cloud or cumulus cloud that's not visible. Another big difference is when there's multiple layers of clouds. From the ground you can watch different layers move with the wind in different directions and you can see through, whereas the satellite is really just taking a one-time snapshot. And if there's different layers, sometimes you can see them, but you really can't tell as much information from the top.
Thanks for all the info, Dr. Chambers. And don't worry, you don't have to memorize all the types of clouds. There's a cloud identification chart on the school website that you can use to help identify the kinds of clouds you're seeing in the sky. To commemorate all the great work done by school, January 13th, the anniversary of the school project, has been designated as Global Cloud Observation Day, and we're all being invited to join the fun. For more information on how to get involved, check out the school website. Go to www.nasa.gov and search for school. That's S''COOL. Well, that's all I've got time for today. You keep your eye on the skies. I'm Amber Whalen. Until next time, hasta luego.